This is a sort of a bonus video that I shouldn't have had to make. It is me teaching stuff that is going way beyond review at this point. This is a set of slides that maybe should have been in a online course for discrete math. But as I have been teaching this course, I've discovered that a number of students have a really shaky background in some of this material, and so I decided to give you an extra bonus video that you shouldn't need, but you may need to help you out. So I'm going to talk for a little bit about sets. This should all be review. If this is not review for you, then you should be going through it like crazy, or going back into discrete math or discrete structures. Okay, so here's an example of a very simple set. It has 4 elements. They are A, B, C, and D. And I like to think of a set as just a bag that has some elements in it. So in this case, here's a bag with A, B, C, and D floating around in it somewhere. Now, since the letters are in this bag, it doesn't really matter what order. We could kind of shake the bag a bit and the letters could change order. That means that this set that I have here is actually exactly the same as the set containing A, C, D, and B. And that's the same as the set containing C, A, B, and D, right? Order does not matter in a set. The other thing that it depends on who you're talking to and the book that you're using, but for the purposes of our class, if you list an item twice in a set, it doesn't really matter. So if we put A in there a couple of times, it doesn't matter. Each item only really appears once. So that means that this set is actually the same as these ones and is just represented by this bag full of stuff. So if we want to talk about the union of two sets, that's really taking all of the elements that are in this first set and putting it together with all of the elements in this second set. So here we've got 2 sets. Our first set, A, B, C, D, 4 elements. A, B, C, and D are in our bag. We want to union that with the set that contains C, D, E, and F. So let's just put C, D, E, and F floating around in here. In this particular example, both sets have 4 elements in it, but it doesn't really matter. So if we are taking the union of these 2 sets, oops, sorry. Right, so if we're taking the union of this first set and the second set, that just means we make a new bag that has everything that is in both the first set and the second set. So let's just shrink this down a little bit so we have a little bit more room. And let's see, so in the first bag we have A, B, C, and D, and we can float them around wherever we want. In the second bag we have C. I can write it again if I want. I'm only going to copy it out once later. We have D, we have E, and F. So the union of my 2 sets is going to be everything that is in this bag, which turns out to be A, B, C, D, E, and F. Right? Similarly, we can take the intersection of 2 sets. So if we want to take the intersection of these 2 sets, that means finding all of the items that are in both of the sets. And so let's take a look. In here we have an A, no A in there, so that's not in the intersection. And we have a B, but no B in here. We have a C, and sure enough we have a C in there. So we need that to add that to our intersection. So there's a new bag, and we'll put that C in there. And we can look again. The last item in here is a D, and there's a D in there. So sure enough, we can put a D in our bag. So the intersection of these two sets is just the set CD. And hopefully that was all pretty trivial for you. Things get more complicated when we start talking about more interesting sets. So for example, we can talk about the empty set, right? And the empty set is just a set with nothing in it, right? So, you know, that's a way to represent the empty set. That's a way to represent the empty set. And here's a way, if I'm drawing pictures, I can represent it. It's just an empty bag. So now let's look at this more complex set, or we have two more complex sets here, okay? So the first one, let's just count how many items are in this set, right? In this set we have one item, the letter A, or the symbol A. This set is a second item. Letter D is a third item. E, F, G altogether is a fourth. Empty set is a fifth. That set of two things is the sixth, and that I is the seventh. So let's just take our bag, and maybe I'll make it a little bit bigger so we have some room to put stuff in. We'll ignore that thing on the bottom for a minute. We'll deal with that set on the bottom in a second. And let's just see what we've got in here. So in here, in our set, the first thing we have is the symbol A, so we can just write that in here. The second thing we have is a set that contains two symbols B and C. So what we need to do is we need to put a new bag in our bag, right? So there's a little bag in our bag, and that bag has a B and a C floating around in it. Next, we've got the symbol D. That's just floating around in our big bag, so we can put that there. Next, we have another bag, right? This is a bag that has, another bag in it. So we've got E, F, and G. So we have E, the set containing F, and G. So let's just deal with this set, and then we'll stick it into the bigger one. So in this set, we have an E, a G, and another set containing F. Let's make this a little bit bigger, and we can put inside there, we've got E, we've got G, and then we have another set inside of there. And inside of that other set, we have this F, so we'll stick that in there. So now we need to take all of the stuff in this bag, right? This whole set is part of this big set that we're trying to figure out. So what I'm going to do is I'm going to take this bag, I'm going to shrink it down a little bit, right? The size of a letter in the bag doesn't really matter. And that's in there. Next up, it looks like we have the empty set in our bag. Well, the empty set is just an empty bag, right? So we'll take that and we'll throw that somewhere. And next up we have, well, look at this. We've got a set that has two items in it. So let me start with a new bag. So there's my bag for my set. It has two items in it. The first item is actually the empty set. So we'll stick an empty little bag in there. And the second item in this little set here is the letter H, so we'll put an H in there somewhere. And now I can take this whole bag and put it in there. And finally, if we look at our set, there's the letter I that's just kind of floating around in there, so there's the I. So this whole big bag here, which has some bags inside of it, and some of those bags have another bag inside of them. Sometimes it's an empty bag. That whole thing represents this complex set here. So I'm just going to take that and put that up there so we can kind of remember it for this first one. Okay. And now let's just take a look at the second set that I have right here, and let's do the same thing for that. So of course we have to start with the big bag. Let's see, what if I put it there for now, and we'll shrink it down later. And in there we can see first it has three elements, an A, a B, and a C. So we'll put A, B, and C in there. Then inside we've got another set that is DEF. So let's get another bag, and into that bag we're going to put D, E, and F just floating around. And of course this, oops, sorry, this bag here is going to go into there. Okay, very good. We also need to have the empty set in there. So let me stick another bag that's the empty set in there. And we need a bag that has the empty set in it, right? And remember that this piece here could also be written like this. It's the set with a set inside it that has nothing, right? It's just that we find that this notation for the empty set makes things a little bit easier. Okay, so back to where we were, we need a bag, and inside of that bag we have to have another bag so that we represent a bag that has an empty bag in it. So there's that. And now we can take this thing and squidge it down so it will fit and put it in there. And it looks like the rest of what we've got in there is pretty simple, just three symbols, G, H, and I. So G, H, and I. Okay. So let's just grab this and shrink it down. And you can see, I don't want to overwrite anything. There you go. It's about as big as I can make it. So this set here is represented by that bag there. So let's take those two sets that we have and figure out what the union of them is, right? So I want to know what that is unioned with that one. And I wish I could draw you the bags here, but it's awfully hard to do that in the software, to copy and paste all that stuff. So I'm just going to do it by hand. So the union of these two sets is really the set that contains everything in this one and everything in this one. So that's not too bad. If we start with this top set, we have an A, we have the set BC, D, and then we have an E, F, G, right? I'm just copying it. I'm going to continue on the next line because I don't have much room. Empty set, the set containing the empty set, and also H and I. And then we just need to look at this one and see, what are we missing? Well, let's see. We have an A. We don't have a B by itself, right? Because if you look, this first one is a B that's already in a bag, right? Rewind the video if you don't remember that. But this one is a B and C that's in an inner bag inside of this outer one. So we need to add a B. We also need to add a C. Looks like we need to add that DEF too. All right, hang on. So let's just shrink that whole thing a bit so we have some more room. And so we got up to the B. We also have a C in here. So let's stick that in. It's going to be a little bit bigger. You'll just have to deal. And then there's the set containing DEF. We didn't have that up there, so we need to add that as well. All right, what's next? The empty set. Oh, well, we had the empty set already, right? There it is. So we could write it again, but no point. So let's just keep going. We have the set containing the empty set. We didn't have that before. So we'll add that. And of course, remember, instead of writing this set containing the empty set, we could have also written the set that, not beautiful, but the set containing the empty set, right? But we'll leave that out for now. So we have the set containing the empty set, there it is. And then we have G, H, and I. Well, G and H are nowhere to be found here, right? They're not in here. I mean, there's a G, but that's in another bag, and there's an H, but that's in another bag. But I is here already. We see it right there. So I just need to add my G, my H, and my close curly, and that's my whole set. Now, if I'm trying to take the intersection of two sets, that's an entirely different problem, right? Now I need to find all of the items that are in here that are also in here, and there's not very many, I don't think. So let's take a look. The intersection of these two sets. Well, I see that A is also in here, so I can write an A. If I look, I don't see a set containing BC down here, so I'll skip that. Is there a D by itself? Nope. A set containing this stuff? Nope. The empty set by itself? Oh yeah, that's there, so we need to add that down below. Just to show you, I mean what I say, we could write that like that here, right? Of course, we could also have written just the empty set in there, but they're both the same thing. This first one here is just a way we represent that in shorthand, because this is hard to draw. But that's fine. We'll do it this way for this time. So we have the empty set where we're here, right? Do we have a set containing the empty set in H in here? No, we don't, but we do have the singleton I. So we will add that, and we've taken the intersection. Okay, I'm really hoping that now you feel a lot better about the material we've covered so far. Unfortunately, there's still a bunch more that you need to see, so let's keep going. We've already talked about how sets are essentially a bag of stuff, right? So, for example, if I have the set A, B, C, D, and maybe we'll add the empty set to that, and the set containing the empty set. So there's my set. If I take that set, we can represent that as a bag of stuff. So that's a big bag of stuff, and in that bag we have an A. So we'll stick an A in there, and we have a B and a C, so let's put them in. And we have, what else? We have this D in a bag, right? So we need to make a new bag that has a D in it. And we have the empty set, so that's a bag with nothing in it. And then we have the set containing the empty set, that's a bag with an empty bag in it. So let's do this first one, which is just an empty bag. And the second one, which is this set that has the empty set in it, is a bag. And in that bag, we're going to put the empty set, which is just an empty bag.
Right.
Okay, so we're going to take this and shrink that and put that up there. So, what we're going to talk about right now is this concept of element versus subset. Let's start with subset. So if I want to know if I have a given set, whether it's a subset of another set, for example, let's suppose I have the set A, B, okay? And I want to know whether this set, whether AB is actually a subset of this one. So let's, just to make our lives a little bit easier, we'll call this set set 2, since it's the second one we made, and we will call this other one set 1. So the question that we have, or that we want to answer is set 2 a subset of set 1? All right, so that's what I want to know. And so to figure that out, what we have to do is we have to say, is every single thing that's in set 2 also inside of set 1? So before we do that, let's just draw what's in set 2. Maybe we'll do set 2 in blue just to make it a little bit different. So set 2 is another bag, and inside of that bag there is an A and a B. So we're just going to put those into set 2. Okay? Alright, so there's set 2. So all we need to do, if we want to figure out whether set 2 is a subset of set 1, we just need to go through every element of set 2 and see if it's in set 1 somewhere. So if I look in set 2, I have an A here, which corresponds to that A there. And we can see, sure enough, that set 1 has an A in it. And we can also see it in there, right? It's just a plain old A. So we can kind of go check. A is in there. Well, what about B? Is B in there? Well, yep, it's there. And we can also see here's my B in my set 2, and it's just floating around in my set 1. So we can put a check mark, and we can say that, yes, indeed, set 2 is definitely a subset of set 1. Okay, so I've cleaned it up a bit, and we can see that set 2 is a subset of set 1. We've said that. Oh, let me move these guys just up here a little bit. All right. So let me make a set 3, which is going to be very similar to set 2, but not quite the same. So set 3 is going to have an A in it. It's going to have a B in it. And it's also going to have a D in it. Okay, so there's my set 3. And if we draw set 3 is just another bag that has A, B, and D floating around in there. Okay, so let's shrink that a little bit, and let's put that there. So if I want to ask the question, is set 3 a subset of set 1? Well, again, I would look at all the elements of set 1 and set 3. So I would say, look, A, well, there's A in set 3, and sure enough, it's in set 1. And B is in set 3, and B is in set 1. And what about D? Well, D is in set 3, and I can see it right here, right? It's just floating around in there. But when I look at the things in set 1, and I have to kind of look at the top level and say, what's in this outer bag? And the answer is that in this outer bag, I have an A, I have a B, I have a C, and then I have just a bunch of bags. So this is a bag, it's got stuff in it, but it's a bag. Here's another bag, it has stuff in it. Here's another bag, it has stuff in it. So if I want to say, is D in set 1? Well, no, it's not. There's a bag with a D in it in set 1, but D itself is not floating around in set 1. So the answer is that S3 is not a subset of set 1. Let me grab that and shrink it down. Ooh, that's good, huh? Okay, so the last thing that I want to do is let's do another set. And we'll call this one set 4. And set 4 is just going to equal the empty set. And remember, the empty set is the same as a couple of curly braces with nothing in it, right? And we can also draw the empty set, right? If we draw it and represent it as a bag, it's a bag that has nothing in it, right? So there's our empty set. And here's my question, which is S4, or is the empty set a subset of, well, let's see, is the empty set a subset of S1? And the empty set is a subset of S1 if everything that's in the empty set is also in S1. So if we look in here, there's nothing in there. So kind of by default, everything that's in here is certainly in there because there's nothing in here. Similarly, we've got this empty bag, nothing in there. So yeah, it's in there. So what we have is the empty set is indeed a subset of S1. And in fact, it's not just a subset of S1, but the empty set is a subset of any set, right? It's even a subset of itself. Anything's a subset of itself. But the empty set is a subset of any set because no matter what set you check with, here you've got nothing to see if it exists in another set. So just to clarify, if I just shrink that for a minute, the reason that the empty set is a subset of this S1 has nothing to do with the fact that there's some empty sets in there. All it has to do is it says, look in this bag. What is in this bag? Everything that's in this bag, check if it's in this one. Well, there's nothing in there, so I don't have to check anything, so it is a subset. So we could also say, you know, is the empty set a subset of S2? And the answer is, of course, yes, because if I say, what's in the empty set? Nothing. So check every single thing in here. Okay, I'm done, right? Every single thing in here, is it part of here? Well, sure, because there's nothing in there. So no matter what is in S2, I know that the empty set is indeed a subset of S2, and in fact the empty set is a subset of everything. So now let's talk about this question of whether something is an element of a set, right? So we can ask the question, for example, is A an element of set 1? And the answer is that A is an element of set 1 if you can find an A inside of this outer bag that represents set 1. So if I look around here, there's an A, so the answer is that yes, indeed, A is an element of set 1. Okay, so let's do another example. Let's try and find out whether the set containing A is an element of set 1. And now let's draw our pictures again, because what we're trying to see is this whole thing, can we find that inside of this set? And this whole thing, if we draw it as a picture, what we end up with is a bag with an A in it, right? And so what I want to know is, do you see in this big bag a bag with an A in it? And the answer is I don't. I see an A by itself. I see a bag with another empty bag in it. I see a bag with nothing in it. I see a bag with a D in it and a B and a C. But nowhere inside of the outer bag do I see a bag with an A in it. So that means that A is not an element of S1. Okay? Let's try another example. Is the empty set an element of S1? Well, the empty set is an element of S1 if, when we look inside this bag, we see the empty set. In other words, if we see a bag with nothing in it. And in fact, we do, right? Because if we look inside this bag, there's a bag with nothing in it. So the empty set is indeed an element of S1. Now, the empty set is not an element of every set, right? Because if we think about for a second, you know, the set AB, well, the set AB is a bag that has an A and a B floating around in it. So now the question I have is, if we call this, maybe, I don't know what number we're up to, so we'll call it S5, is the empty set an element of S5? So let's take this guy and shrink it. We already said the empty set is indeed an element of S1, but our question now is, is the empty set an element of S5? Right, that's our question. And the empty set is an element of S5 if we can find this bag somewhere inside of this one. And when I look, I don't see an empty bag in there. I see an A and I see a B, but I don't see an empty bag. So it's not an element of S5. So even though the empty set is a subset of every single set, the empty set is not an element of S5. So how is it a subset but not an element? Well, remember that when we talk about the concept of subset, when we're talking about subset, for example, if we are asking, is S5 a subset of S1, then we're asking, if I look inside of S5's bag and look at every single thing in the bag, do I also find that in S1's bag? When I'm talking about element, then I'm saying, is this thing, which is not necessarily a bag, found in my bag? So if I want to say, is D an element of S5, right? Then what I'm saying is, when I look in the S5 bag, do I see a D, right? And that's very different from saying, is everything in one set in another? So subset, you absolutely have to have two sets. I can never ever ask, is D a subset of S5? Because D isn't a set. And in order to have a subset, you have to have a set. But I can say, is D an element of S5? Now, if I want to look for elements, I can always take a set and find out if that's an element of another set. Because, for example, in here, I have the set containing D is an element of S1. Because when I look inside S1, the set containing D is in there. So let me just try and clarify one more time. Let's suppose that I have a very simple set. So let's consider, let's suppose I have the set, still have no clue what we're up to, S7, and S7 is the set A, comma B, comma C. It is the case that the set containing just A, which we'll call S8. Now, it is the case that S8 is a subset of S7, because if we go through everything that happens to be in S8, let's see, what's in S8? Oh, there's an A. Then I say, oh yeah, that's in S7 too. So for subset, both sides of the subset equation have to be sets, because what you're saying is everything in this first set can also be found in this second set. So I have an A in there, I have an A in there, so I say, yep, it's a subset. So let's shrink this stuff and put it up there. So let's make an S9, and let's let S9 be the set containing A, B. And here's my question, is S9 a subset of S7? Well, the first question you have to ask yourself is, are they both sets? And yep, S9 is a set, S7 is a set, so far so good. And then we say go through everything in S9 and see if it's in S7. So A is in S9, A is in S7. B is in S9, B is in S7. I'm done, so I say, yep, S9 is a subset of S7. Let's try one more. Is S9 a subset of S8? Well, let's see. The first thing we need to do is we need to make sure they're both sets, because you can only do subset if they're both sets. So S9 is a set, S8 is a set, so we're good. And then you have to go through set 9 and say, is everything that's in set 9 also in set 8? So we look and we say, A is in set 9, A is in set 8. So far, so good. B is in set 9. Uh-oh, B's not in set 8. That means that S9 is not a subset of S8. In fact, S8 is a subset of S9, right? Because everything in S8 exists in S9, but not the other way around. Furthermore, if they were both subsets of each other, then they'd be the same set. Okay, so that's all about subset. And remember, one of the most important things about subset is you can only have a subset if the thing on the left of the subset symbol is a set and the thing on the right of the symbol is a set. So we've talked about subset. Now let's talk about element. When you're talking about element, usually, traditionally, when you were doing this in high school, the thing on the left was not a set. So when you're trying to figure out something like, why don't we underline element in blue, and I'll do my element stuff in blue. So if you want to know, is A an element of S7? Notice that the thing on the left, A, is not a set, but S7, if we look at it, has these set brackets. So S7 is a set. When you have element, the thing on the right has to be a set. The thing on the left can be a set, but doesn't have to be. So if I want to say, is A an element of S7, I say, let me see if I can find this thing in S7. So I look in S7, and I see an A floating around in the bag. So I say, yes, indeed, A is an element of S7. Okay, let's try something else. Is the set containing A an element of S7? Okay? And the set containing A is an element of S7. This is an element of this. If the thing on the right is a set, well, it is. And if this thing appears inside of this thing, so this is an A in a bag. And I say, is there an A in the bag inside of S7? No, there is not. So the set containing A is not an element of S7. Having said that, we know that the set A is indeed a subset of S7, right? Because now we've got a set on the left, a set on the right, and everything that's in here is also in here. So let's just take a look at this set 1 again that we had from before, and let's talk about some other elements that are in here. So when I look, I see A in there, so A is an element of S1. B is in there, so B is an element of S1. I see a bag with nothing in it in there, so that means the empty set is an element of S1. But the empty set's not inside of S9, so we can say that the empty set is an element of S1, but the empty set is not an element of S9, because if we look in this one, there are no empty bags in S9. Even though the empty set is a subset of S9, because the empty set is a subset of every set.